All right, this is the review for chapter 4. I just put some new lead in my pencil, so I'm ready to go. Here we go. The two triangles are congruent. Find the value of C and determine, and see, the diagrams are not to scale. All right, so C is located down here at the bottom, and it looks like straight across from C is going to be the number 3, so C is equal to 3, and so that would be B. Now, I realize all of these problems only have 2 answers to them, but make sure you know how to do them and not just say, oh, I'm going to pick one of these. All right, the next one, justify the 2 steps of the proof, the last 2 steps. Okay, when you do this proof, go through and mark it up. So RS, line segment RS and UT are congruent. That was given to you. RT and US are congruent. So RT, this one here, and US, this one here, are congruent. So ST is congruent to TS, so that's this line right here. It's congruent to itself because of the reflexive property. See itself in the mirror, reflexive. Now, because I see side, 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 I can say that triangle RST is congruent to triangle UST because of side, side, side. Again, whenever you write the triangle, you need your one of 5 ways of proving the triangles are congruent. So this one's going to be B. Next one, state whether triangle ABC and AED are congruent. So ABC is this triangle, and AED is this triangle. So if you take a look, you have an angle, a side, and a side. Angle, side, side. We do not have any donkeys. Angle, side, side. Or if you switch it around, if it was side, angle, side, the angle would have to fall in between the 2 sides. And as you can see here, the angle does not fall in between the 2 sides, so I can't use that one. So this would be no, there's not enough information. So D. Name the angle included by PN, so PN and NM. So name the angle, so the angle is going to be N. Angle N. Notice it has N in both of them. So this one is A. And each pair congruent. What pair of triangles are congruent by angle, side, angle? So the side is in between the 2 angles. The side is in between the 2 angles in both of these, so B. What is the missing reason for the 2-column proof? Okay. So AC bisects angle DAB. DAB. Now, a lot of you are having problems with this because you're not looking at the angles that they're talking about. Bisect means it cuts it in half. So it's going to cut this angle in half. So what happens when it cuts it in half? It forms 2 new angles. So what are those angles? Angle DAC and angle BAC. So DAC and BAC. And why did it do that? Made those equal? It's because of the definition of an angle bisector. So the definition of an angle bisector cuts that big angle into 2 small angles, and you name those 2 small angles. All right, so AC is equal to AC, so this is equal to itself. And then we come back again, CA cuts angle DCB, so this one over here. So that's going to make these 2 angles equal, again, by definition of a bisector. So I have an angle, a side, and an angle. Angle, side, angle. And that's going to be A. From the information, can you say that FDG is congruent to FDE? I have an angle. This is equal to itself. So angle, side, and angle. So yes, by angle, side, angle. Supply the missing reason to complete the proof. All right, so angle Q is congruent to angle T. So this angle here is congruent to this angle here that was given to you. And line segment QR, so this is equal to TR, which is right here. So now if you take a look, you have some vertical angles, right? It crosses, so you should think vertical angles. So angle PRQ is congruent to angle TRS. It has their vertical angles. So why are the two triangles congruent? By one of those 5 reasons: angle, side, and an angle. So angle, side, angle. And then why is PR congruent to SR? Because of CPCTC. So it looks like that's A. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. All right. There was a postulate that if you have an isosceles triangle and your vertex angles are congruent to each other, in other words, this bisects the vertex angle, then down at the bottom here is going to be a right angle. So x is equal to 90. And then to find y, I'm going to take 90 and subtract the 47 and get 43. So A. In an A-frame home, so I have an A-frame home that looks like this. 2 congruent sides extend from the ground to form a 34-degree angle at the peak. So my vertex is 34. So 180 minus 34, 6. So that's going to leave me with 147. Now, each one of these angles at the bottom can't be 147. So these two angles we know are congruent to each other because they're across from the two congruent sides. So I'm going to divide this by 2 and get 73. So 73 is my answer, which is B, not the 146. All right, so if this is 116, 180 minus 116, or 764. Again, each one of these angles can't be 64 and this 116, so I divide that by 2 and get 32. So A. Find the value of x. Okay, if we take a look, this angle and this angle are the same, 3x minus 50. These two form a linear pair or supplementary angles. So 3x minus 50 plus my 7x is going to equal 180 degrees. So that'll give me 10x minus 50 is equal to 180. Add 50 to both sides because it says subtract. So 10x then equals 230, so x then equals 23. A. List of 6 parts. All right, so angles. So angle P is going to be congruent to angle T. Angle P is congruent to angle T. Angle Q is going to be congruent to angle S. Now, this next one is going to cause problems because you can't have angle R congruent to angle R. So you have to tell what angles you're talking about. Again, be a little bit more detailed. So angle PRQ is congruent to angle TRS. Watch out for that because I'm going to take it off on the test. All right, and then you have your sides. So PQ is going to have to be congruent to TS. QR is going to have to be congruent to SR and first and third. So PR is going to be congruent to TR.